that work very well are desperately needed for PTSD. What we have found in our ketamine studies, the first study being a single dose and the current study looking at repeated dosing, is that ketamine can have very robust effectiveness in PTSD and it can work right away.
In this study, the group of patients who received ketamine, in that group, 67% or 2/3 showed rapid and significant improvement in symptoms. So ketamine is a very promising treatment because it seems to lead to robust improvement in PTSD symptoms and a rapid improvement.
The available drugs for PTSD take weeks to months to work. And given the seriousness of PTSD, that's too long. They need to feel better immediately, and ketamine potentially has that effect.
Even participants who had experienced trauma in childhood talked about feeling more normal, being able to face their fears, their trauma memories. Some of them had nightmares that resolved completely. The infusions really made a difference in a short period of time. The next steps in ketamine research for the treatment of PTSD are to study how to maintain this initial improvement in PTSD symptoms, either by adding further infusions over time or potentially evaluating whether combining psychotherapy with ketamine infusions for PTSD might have a synergistic effect. This is an important discovery. We have now shown that ketamine not only works for individuals with treatment-resistant depression, but also for patients with chronic PTSD, a population very much in need of novel treatments.
The over-excitation of neurons by glutamate, if gone unchecked, can damage neurons and eventually kill them. This phenomenon is called excitotoxicity. Because of this, the brain has reuptake pumps that rapidly, while using a lot of energy, release glutamate from the extracellular space back inside the cell to prevent it from stimulating too many receptors. Effects of ketamine on glutamate receptors. Ketamine's highest affinity interactions are with one of the receptors for the neurotransmitter glutamate. Glutamate is a common amino acid building block of proteins and the most prevalent excitatory neurotransmitter in the brain. Nearly all networks in the brain rely on glutamate for synaptic transmission between neurons. As such, glutamate has been implicated in nearly all brain functions, ranging from simple reflex reaction to emotional regulation, memory consolidation, and complex cognitive constructs such as attention. Glutamate is also heavily implicated in neurodegeneration and cell death. Ketamine selectively targets networks of neurons that are engaged in specific functions. This could be an emotional or mood-related network that is producing reverberating thoughts, contributing to depressive symptoms or flashbacks related to PTSD, hypervigilance, allostatic load, and migraine prevention. Migraine is a neurological disease affecting 1 in 8 people. Symptoms include nausea and/or sensitivity to light and sound, and a throbbing headache. Although certain genes may increase the likelihood of migraine, environmental stimuli and molecules that increase the sensitivity of brain blood vessels and their innervations also play a role. during a migraine attack, nerves in the brain are activated, leading to increased sensitivity to stimuli, lowering the future threshold for activation and making patients hypervigilant. Chronic repeated exposure to certain stimuli can also lower this activation threshold, such that relatively innocuous stimuli can trigger an attack. Excessive use of certain migraine treatments can increase headache frequency over time and produce unwanted side effects. Thus, selective agents are needed that specifically target the systems and pathways affected in migraine pathophysiology. When glutamate activates the neurons that release inhibitory neurotransmitters, the downstream effect is inhibition of surrounding cells. This interplay of excitation and inhibition provides a balance that is important for information processing in the brain, especially for the so-called higher order functions of cognitive and emotional processing and decision making. By preferentially blocking the excitation of inhibitory neurons, ketamine indirectly increases overall neuronal activity, a process called disinhibition. During an acute migraine attack, the trigeminal nerve is activated, peripheral sensitization. Increased allostatic load, the consequence of chronic repeated exposure to stressors, leads to central sensitization, lowering the threshold for future neuronal activation. Hypervigilance. Ostensibly innocuous stressors are then sufficient to trigger an attack. Medications that reduce sensitization may help patients who are hypervigilant. Ketamine has considerable affinity at several opioid receptors. Opioid neurotransmitters are a group of peptides, small proteins, with multiple functions, including modulation of mood and sense of well-being, and modulation of pain perception. Depending on the receptor subtype, ketamine has both agonist and antagonist properties. Ketamine's actions on these receptors likely contribute to its acute analgesic pain reduction properties. The connections between stress and suffering. How symptoms are situational. Stress and symptoms. It is in the nature of chronic diseases and trauma that symptoms manifest most when our survival instincts, fight, flight, freeze, take over our body's function. We need to have a better guess as to what parts of the system are dysregulated and how to communicate with those parts. It begins with a reframe of pain at the top left of this image. In this model, muscle tension, posture, dysautonomia, inflammation are not necessarily causes of headache. They are all protective behaviors driven by a perception of threat. Who's perceiving threat? The trigeminal system and its ANS immune connections. This is why the severity and range of symptoms can vary moment to moment, hour to hour, or day by day, according to how stressed or how relaxed we are in that moment, for most chronic diseases. Here, I use the word stress in its widest possible interpretation to denote anything which may be troubling us in the present moment, e.g., feelings, accidents, trauma, troublesome relationships, financial problems, small unresolved situations from childhood that may seem insignificant to an adult. It is not possible to glean these most essential clues unless we stop looking at the problem as just a brain damage issue, or as simply a disruption in chemical systems, which are in fact more complex than any scientist can get to the bottom of in an entire lifetime. Instead, we can look to the behaviors of wild animals. Fight, flight, freeze. How does it look like in animals? Humans have the same instincts as animals. The current approach to chronic diseases won't change until enough people understand this real-world evidence. New textbooks are written and the old knowledge passes out of memory, maybe 30 to 50 years from now. Most people can not afford to wait for the clinic proof to be in place, so have a choice to make. Give this real-life evidence-based knowledge due thought and attention, change habits, and continue to make this choice every day for life. Or just continue to stay with whichever devastating symptoms manifest and fulfill the current belief that there is nothing that can be done but degenerate. Suffering is situational. It is easy to prove this idea by studying one person at a time, but there will probably never be support for large-scale trials, or the millions of dollars that these would cost. Instead, we must use our logical skills, do our own research, and test out on ourselves. One of the principal tests we can perform on ourselves or with anyone affected by chronic disease is to observe whether symptoms vary over short time scales, either hour by hour or day by day. If they do fluctuate, then there is a reason for this, and it is probably stress related. We can investigate this for ourselves by keeping diary notes to see which factors provoke the change in symptoms, e.g., diet, sunlight, weather, moon, temperature, humidity, or the company we keep. Indeed, many people with chronic conditions will have encountered the experience of symptoms like tremors becoming more significant in restaurants when people are watching, or freeze in crowds when there is a need to hurry. What is then behind the change in symptoms? While we are now more aware of lifestyle diseases, such as being overweight and smoking, we have turned a blind eye to our instinctual stress responses. Hard physical work and exercise helps because it burns off the excess adrenaline that people produce during a hectic day at the office. It helps us to fulfill the cycle of instincts towards a calm body, which the animals do by running away or fighting. Pain is strange in that it is non-linear and quickly becomes amplified over and above what is happening in the tissues. A leading definition emerging from the latest research is that pain emerges when your brain decides something is unsafe. At the core of the experience of pain is a decision made inside the threat detection systems, the immune system, and by the brain. Pain is like a warning signal saying something is not right here, to tell you to do something different. As Paul Ingraham states in his article Sensitization in Chronic Pain, pain is, at a very fundamental level, all about your brain's assessment of safety. Unsafe things hurt. If your brain thinks you're safe, pain goes down. It is clear that pain is a complex emotional event. New pain science is revealing that many things contribute to people's experience of pain beyond our physical structure and tissues, including the story you have about the pain. When it comes to changing the way we perceive pain, we can try to sell ourselves more beautiful, elegant, and accurate stories. For example, if you've been told you're experiencing back pain because you're old or because your back is out of line, you could help the experiencing of pain to ease by reframing it as an alarm signal or danger message that is retrainable. Summary: the severity and range of symptoms often vary considerably with the situation we are currently in. Examples include the differences in symptoms when we are in crowds or in good company, in summer or winter, and in particular in stress or in relaxation. Any good theory of chronic disease needs to explain these fluctuations, and I propose that getting stuck in survival instincts mode or defensive stress states is, in the majority of cases, the greatest factor that negatively impacts on symptoms. Likewise, learning how to relax and how to get unstuck from our survival instincts is the most beneficial factor and quickest route for reducing symptoms.